Hello world, my name is Stefan and today we continue building a benchmarking library for Roslyn components. To be more precise, C# Roslyn components. This would be the first season, so to say, and in the second season then we will build the benchmarking library for Visual Basic Roslyn components. So yeah, in today's session we will have a look at what we did last time and also a bit of cleanup that I did off stream. Then we will continue building the types that can be used for benchmarking of I-incremental generators, which are the generator types which have been added in the .NET 6 SDK or in Roslyn version 4.0. So we have a couple of tests, all of them are green. Let's have a look at our solution. An issue that we had, or I had last time, was with the having several directory.build.props files, and they didn't seem to get merged correctly. I wasn't sure what the issue is. I basically created them anew, and now they're working. So we have our folder structure is we have samples, the production source code, and tests, and all of them have their own directory.build.props file, which includes includes only for that kind of project, such as the testing projects. They need testing framework, also can collect code coverage, and have the implicit using for XUnit, which wouldn't make sense for production code or other projects. Also, all our test projects are not packable. However, the production code is. And for the production code, we have all the NuGet, all the properties that we need in order to later on publish a NuGet package. So this merging is now fixed because there is also one root directory.build.prop file which applies to all. So this works by having this import statement, which basically searches up the directory hierarchy until the next directory.build.props file is found. And which is this one in the root, where we set, for example, if we have a CSproj file, we use the language version 10. But for a Visual Basic file, we use the language version 16.9, which are the latest language versions, C#10 and Visual Basic 16.9 respectively. An interesting issue that I had there previously, or because I also added now Visual Basic projects to the solution. They haven't been there before. So because we are targeting Net Standard 2.0, the default language version of Net Standard 2.0 is 7.3. However, I would like to use the latest C#10, so I need to explicitly set it. And this is why we explicitly need to set it. However, we need to differentiate between whether if it's Visual Basic or a C# project. And previously I used an approach where I made the condition on the language and then had it checked for C# or VB, but this didn't work. So I had it pretty much like, no, it doesn't say like here, but basically it was, the condition was if the language is C#, or down here if the language was VB. But this didn't work because the directory.build.props files, they are imported rather early, and then this property is not set yet. So as always, Martin Ulrich yields all the answers when it comes to MS Build, and he suggested to use the MS Build project extension, where we can then select either CSproj or VBproj. And this is how we can have our CSproj settings here, where we also enable nullable and implicit usings, which doesn't exist in Visual Basic, and Visual Basic specific settings. I'm not all too familiar with Visual Basic just yet, but in the second season when we built this, I hope I gain more, and maybe we have some more Visual Basic specific settings here as well. I've also set CLS compliant attribute. I actually haven't really ever used it. Currently I enable it for all. I guess later on it may be better to set it for the shared projects, which are then consumed by both Visual Basic and C# specific projects. And for the specific projects, perhaps disable it, but I'm not too sure all about that just yet. Okay, so let's jump to the solution. Yeah, what we added is the equivalents to the C# projects. We now have the Visual Basic equivalent, which then we will tackle in season 2. And we built last time the type, the benchmarking type for incremental source generators. And it looked similar like this, where we make it generic to accept any incremental generator, which must have an accessible parameterless constructor, so that we can actually new it down here. And I also did a bit of renaming. So for the initialize and the inspect phase, this is basically the 3 phases. So in the initialize, we set up the benchmark with all the options we want. The invoke phase, this is the one which should be only doing the generator work, or as much as only doing the generator work, which is then invoked by, for example, benchmark.net a lot of times in order to create the measurements. And then the inspect phase is basically an assertion to verify that everything was right or roughly right. It's not as precise as unit testing, but it should give a bit of a sanity check. Perhaps smoke testing, well, somewhat applies. And previously had those types that we pass in. I called them options. I now switched to the name context, because this is also what generators are using. If we jump to the interface here, the incremental generator that you need to implement in order to have incremental generator, they use the name context here. And I also, those types were derived previously from base types. I removed that because I didn't quite need this yet. I will then later on reintroduce this when we actually have also the implementation for a different assembly for the source generator, the iSource generator, which is the Roslyn 3.8 or .NET 5 SDK generators, and also other Roslyn components such as analyzers, suppressors, code fixes, and refactorings. Okay, and yeah, so what we do is in the initialization, we create our generator driver. Then in the invocation phase, we run it. I actually exchanged this to just 1 generators, and the 1 generators and update compilation that I had previously up here, I now only use in the inspection phase, because this is where we need the output compilation and the diagnostics in order to verify that everything is right. And in the inspect, previously I had all the if checks basically for verification all in here. I now move this to separate classes. So I have the inspector, which basically checks what we had previously, if the diagnostics are as expected, if the syntax tree is as expected, and we can also compare sources via this diff, which uses a library called diffplex, where we basically build up a source where what has changed, plus and minus between what was expected, what was the actual. And yeah, so that's pretty much it. And the, well, one last change is the exception. I renamed it to the benchmark inspection exception, and I have static throw methods which do not return. And then improved a bit the formatting of the output message. And let me check my notes. Yes, so this is pretty much what I did off stream, basically a bit of cleanup. Logically, nothing really has changed. And now let's continue. I still have quite some to-dos from the previous session, like these. Also added a couple of new ones, like doing null checks, because we have all the .NET 6 SDK analyzer, and we have, for example, here warning because we do not null check the type that we pass in here in a public method. But basically, previously, I actually just did the null check, but that was bad because I didn't write a unit test before. So I will do it properly this time. Actually, let's start with that. So I have here to-dos. So the initialize and also the inspect should throw if we pass in null. So let's have unit tests for that. Let's jump to the equivalent unit test project, which is for C# incremental generators. Let's add a new fact. We're using XUnit here. Zoom in a bit more. So this is the initialize. When we call it with null, throws. Where we create, previously I had just one generator. Actually, this is the last change. I forgot to mention this. Previously, we had a more simple generator for testing. In this generator, I basically now do everything. So this is all the providers that we have. We have a syntax provider, compilation. Where is it? The compilation provider, parse options provider, and so on. And then for each thing that was provided, basically write it to a source file with I start a comment and, for example, print out the number of nodes which have been found, the language which is in use. We also have some to-dos here to check for additional texts, but we still need to provide that. And also an empty generator, which is the null generator, which does nothing. And for that, we can use the null generator because we don't need any real logic here. We won't actually really call into the generator. And let's say benchmark.initialize. If we pass in null, we actually get a warning because we enabled nullable reference types and we declared this options type to be passed at the C# incremental generator benchmark initialization context. We declare this as non-nullable, so there is no question mark. But in this test, I actually want it to fail, so I will suppress the warning with the null forgiven operator. And this is an action. And so in C# 10, we could actually write var because it now supports natural lambda types, but I do prefer explicit declaration. And this now should throw. In XUnit, this would look like assert.throws. It should throw the argument null exception. And we pass in the initialize. It also has an overload where we can check for the parameter name. Which is in our case, I believe, context. Yes. We could also use something like fluent assertion. In fluent assertion, it would look like initialize.should.throw exactly type of the exception. And we pass in the lambda. No, we don't pass it in because we have it here. And then I believe we can then say something like which.param name which is the one from this exception. So this property dot should be context. And yeah, but if we only have a couple of assertions here, I will stick with the XUnit assertion framework for now. If we have more complex assertion statements, perhaps I will introduce fluent assertions later on. Okay, and we basically need the same test for the not invocation but inspection. So we inspect, basically the same, also context should also throw. Let's run the first test, see it fail. It turns red. It says object, yeah, we get an object reference not set, but we expected argument null exception. So let's throw it. There are several ways of doing that. I'll say if this is null, then throw new argument null exception, and we pass in the name of the parameter. Actually, not do this at the beginning, so now we run that. It now fails because well, we now do throw the expected exception, but the expected was context, so the parameter name, but we haven't set it, which means we can now pass it best with a name of. We could also say like context here as a string, but if we change that name, so it isn't really linked to that, so I prefer the name of here. I think there's also an analyzer, isn't it? If it says, yeah, use name of in place of the literal. So enabling this, the analyzers from the SDK, which you can do by, let's jump to the directory build.props, by enabling the net analyzers, which you need to do here explicitly because we're targeting net standard. If you target .NET 5 and up, it's enabled by default, but not all of them. Only, we had a look at this last time, only like 10 or 15 diagnostics from this, or analyzers from this SDK are enabled. If you want to have all, set the analysis mode to all. Okay, so this test now should pass. It does not. Which surprises me. Expected context. Palm name. I'm not sure why it fails. Interesting. Oh, I guess this is something else failing. No, it is failing here. What am I doing wrong? Yes, argument value cannot be null. I have no idea. Let's see about this test. Throws, is there another overload? Throws. No, should be it. Yes, because we didn't actually throw. So let's do this here as well. if context is null, then throw new argument, null exception. With the name of context. Do I have some updating issues? Because let's run it from the test explorer. This shouldn't make any difference. It doesn't. I'm doing something wrong. I'm doing something else wrong. Am I not? So we're going into this benchmark, calling into this method. If it is null, throw. Is this not working? Context is null. This should have been like a warm-up, and I failed dramatically. But why? Benchmark. Inspect. Am I not? Am I calling the wrong method here? Yes, okay. Yeah, no, I am calling inspect. Let's see what's going on. Oops. Is it not built or something? It seems that the source is like... Let's check the truth. Oh, because I'm in the folder view, is that why? And not in the solution view, and then it didn't get updated? So in the Solution Explorer, I was having the folder view from before and not switch back to the solution view. Is that it? That seems... Ah, okay. Okay. So if in the folder view, Visual Studio doesn't update the solution when... Or the testing Explorer at least then doesn't. So the testing Explorer needs the solution view to be active. Okay. Great. 2 passing tests. Hui. Well, learned something. So we should be able to go back to the more concise syntax with using the null coalescing operator and the discard pattern. I think this is called like the standalone discard pattern if it's combined with null coalescing. I think, isn't it? Stand alone discard. A standalone discard, yeah. Again, every link that we visit, I then put into the GitHub discussion for later reference. Okay. What I would like to do is, if we had .NET 6, Hello Segmenti, thank you very much for following. Not sure when you tuned in, but we're building a library which has benchmarking components for Roslyn elements, such as, in this case, source generators. Thanks for following. I really appreciate it. Thank you. So if we were using .NET 6, we could use argument null exception .throw. No, throw, but throw if null. Let's have a look at source.net. And we have it here, so if null. I really like it, but since we're targeting net standard 2.0, we can't use it. So I would like to use something similar. I would like to use what would have been added, but actually was discarded again for C# 11, the null checking operator. Not sure what the official name was. If we go to sharplab, not sure which branch this is on. Say string, where we have the double exclamation point, how is it called? Exclamation token. Then, okay, tweet branch. It has been cut from C# 11, so maybe it's on this branch, still available. There it is, yes. So it would have turned the double exclamation token into a compiler generated null check. And I would love to use this. So perhaps I put this into a class. Inspection. I call this, how is this usually called? I think throw helper. Internal static class. Internal. I usually make everything internal first, unless I have evidence that I need it to be public. Internal static void throw if null. Basically use the similar syntax which would have been. So we have, but that's not, okay. Okay, what we don't have is, because it's compiler generated, this call argument expression. But again, this only exists in net, I think in .NET Core 3 and 2.1 and upwards, but is used since C# 10. I will stick with that for now. Perhaps if we do multi-targeting it later on, actually have .NET 6, maybe then a switch, but yeah, this would, no, what I was about to do here isn't really worth the effort. This is concise enough as well, in my opinion. Okay, so to the next test. We have a couple of to-dos here. So I had this previously, but commented it out to print out diagnostics. So what I wanted to do is to do it properly, a bit more test-driven. What if we expect diagnostics? Because a generator can produce diagnostics. If we go to our test generator, perhaps let's have it produce a diagnostic. Let's say context.report diagnostic, and then actually check for diagnostics as well. This gets in a diagnostic. So let's create this diagnostic. I think it's .create, yes. Okay, we can omit the name here because we have it on the right side. And it requires a diagnostic descriptor, a location, and args. Do we really need a descriptor? Yeah, let's do it. Let's do it properly. So let's have a descriptor. Private static read only diagnostic descriptor. Let's call it rule. Let's create an object initializer. And oops, no, it's not an object initializer. We need to pass it all down. So we have ID, title, message, category, diagnostic severity, is enabled by default, description, some help link, and custom tags. Okay. So the ID, let's call it incremental generator 0001. The title is test, or let's call it test title. We have the test message, test category. Let's make it a warning. Test description, some test. How's it called? Help link URI. And a tag, a test tag. One part can also contain a message format. So that's the message. It's actually a format. So we can say test message and some variable. And let's create the diagnostic. So we pass in the rule. Now we need a location. And as args, let's pass in something from our compilation, perhaps language version. Or do we have something else in the pass options? Now let's use the language version. Now for the location. It's nullable, so we don't necessarily need a location. That's for now. Use null. We'll take a look at the location later. Now I want to make it expectable so that we can also expect a diagnostic to be produced. Okay, so we want for our inspection phase, actually let's use this test. So let's have a look at this test. This is the source that we expect. So what we showed earlier, we have like 0 nodes because we basically pass in empty. Language is C# and some other options. And well, if we don't pass anything, it should be nothing in our case. Or we can make it on the number of nodes. So let's jump to the generator and let's say, let's report the diagnostic if we have any nodes. That's in source dot nodes dot length. Or is there? It's an immutable array, so there is an is empty If it is not empty, then we create a diagnostic. So for the other test, where we actually have some source, okay, well, I just pass in an empty string, but there is this is one node. What node is it actually? I'm not sure. No, I need to jump to the generator. Do a breakpoint here. Run the test. I guess a compilation node, perhaps. Compilation unit. Syntax, compilation unit, okay. So compilation unit. That's the root of a syntax tree, I guess. And if we have any, then let's create a diagnostic. So in this case, we need to expect a diagnostic. But how can we pass this in? Well, we could perhaps create a diagnostic. So if we pass into the incremental generator inspection context, we could make a property. I make all of them init for now. When we lay this when we move this to a base class, which could also be consumed by Visual Basic, I need to have a look if this is actually working with Visual Basic. I have no idea, but we'll take care of this later. And let's pass in an. Should I make it an immutable array or just an IEnumerable? IEnumerable of diagnostic. And perhaps per default, let's make it an array.empty diagnostic. Okay, this is not CLS compliant, but yeah, I will take care of CLS compliance later. Diagnostics. Diagnostic dot create, and this could be the expected diagnostic, but the syntax is for like a quick assertion is a bit clunky is the wrong word, but also what I would like to have is similar than the testing framework from Microsoft, microsoft.codeanalysis.testing, where let's briefly jump to a example. Project templates, C# diagnostic test. Yes, I would like to have like this syntax where we pass in open brace pipe number of a location. So this is location 0, colon, source text, then again the pipe and the closing brace. So we have opening brace, pipe number, then we have here some integer, colon as an opener and as a closer pipe and closing brace. And I would like to have this syntax as well, so we can mark expected diagnostics. So perhaps in our case, let's copy this. So in our case, let's actually have the generator create something. Let's do a public class and class, and we expect a diagnostic here because in the generator we could also, can we do it like down here? We can also search for, no, we don't need this here, but we can do it here. If the node provided is a class declaration syntax, then, oops, need to use a verbatim because class is a keyword. Then we can add this to, aha, is this, oh no, I can't really do this here and also count the nodes. I'll do it down here. So in here, let's iterate through all the nodes. And if this node is a class declaration syntax, then we create a diagnostic. And we use the location of the class. No, not the class, but perhaps the class should have a, how does a class look like? Let's have a look in the syntax visualizer. I installed this with Visual Studio. And so class declaration has an identifier, okay. Identifier, and we could use the location of this one. Okay, so this will be our location. So we report on the identifier of this class. And this could also be the, perhaps this is a better parameter to it than the, oops, I closed the class generator. Then the language version, we can pass in the name of the identifier. Dot the syntax token, and the syntax token has, I believe, a value. Yes, dot value text. Okay. So we expect now a diagnostic with the name of the class, which is class in this case. But creating it like this is difficult or even impossible because the standard diagnostic doesn't know like this is syntax, so we need to parse it manually and we need to pass in this location. So I guess we need a custom type. How do we call it? Test diagnostic, inspection, diagnostic inspection, diagnostic. Well, it's a resulting, it's just a diagnostic. Diagnostic, I don't know yet. I call it test diagnostic for now. So let's create ourselves a new class. Test diagnostic. And what do we need at least for diagnostic to make sense? It needs an ID. Or let's have a look at the diagnostic, at the actual diagnostic from Microsoft.code analysis. We have the script, we have like this. This seems to be more complete. Let's copy it in here. So yeah, we always need an ID category. Good. Well, let's make it strict for now. We can always make it less strict later on. We have a message. We have a severity. Default severity, no, we don't need that. We need the effective severity. Is enabled by default. We don't need either because it should be there. Warning level, always forget what this is suppressed. So is suppressed, we need later on for diagnostic suppressors, but this will be a future episode. A title, a description. Help link. Location, but the location we take from the markup. So I think this should be an int. So let's call this markup location, because I think this is also called in the testing framework. I will open a solution on this side and then have a look at how this is called in the testing testing library from Microsoft tags. Okay, this seems to be rather tedious to set up, to have this big constructor. I think I make this Roslyn style, make this type immutable, and then have a lot of width. Why make it a record? Let's make it a record. And we also have properties. But let's make that a sealed record class. Ah, yes, we have C# 10, so this should be possible. And we create a bunch of properties. We have the string ID, the string category, the string message, the severity, a string title, a string with the description, a string with the help link, the markup location, some custom tags. Perhaps we should initialize these as array.empty. And properties. There should be an empty here as well, isn't it? Oh no, immutable dictionary of string dot empty. This does not exist. Ah, yes, it does. Also, it's not a method, it's a property, yes. And ah, yeah, key is not, but the value maybe now. Okay. So, well, this could all be null if it's not set. Make it all optional and perhaps only check for these which we actually set. Okay. Hidden. Okay. And now let's create our test diagnostic. Create an object initializer. Here we have it. So this needs to be the test diagnostic as well. Since this type is public, we need to make this one public too. Okay. Yes. And we have an, let's format this like so. Well, let's start simple. Let's do just the ID. Incremental generator 0001. Let's ignore the rest for now. So we now expect one diagnostic to occur. So in our benchmark inspection phase, we need to check the diagnostics. Okay, so let's have a overload here. And okay, perhaps we don't need this anymore, but also the can remove later on. Always. So the expected are the ones that we receive, and the actual are the ones that one generate and update compilation from the driver returns via the out parameter. Okay. So we need an overload of this, which takes as expected an I enumerable of test diagnostic. Okay, let's iterate them. Let's do a expected. Let's call it diagnostics is expected to array. And so they need to have the same. Also, yeah, should be an array. Okay, same length. And if they do not, we throw. And if they do, we still need to check now basically compare the diagnostics. So we need a for loop. We iterate through all the diagnostics. So they do have the same length, so we can now get the test diagnostic expected diagnostic is diagnostic at position I, and actual at position I is the actual diagnostic. And I have a typo. Now let's compare them. We can say if the expected diagnostic.id does not equal, let's do a string equals, the actual diagnostic.id, then we have a problem. We also should use string comparison. We make an ordinal comparison. And this is not a test diagnostic, but a regular diagnostic. Okay. And is not null yet. This could be null. No, difference of possible null reference. I declared this as none. Nullable. Why could the ID? Yes, the ID could be null. Yeah. My bad. So if the ID, so we only want to compare actually if the ID is not null and they are not equal, then we have an issue. Then we throw our benchmark inspection exception and say unexpected diagnostic number I diagnostic ID of, or let's call it unexpected ID of diagnostic number I, where we say the actual ID is expected diagnostic.id and the and the actual is actual diagnostic.id. Okay, so let's see if we can get a failing test if we pass in something different here. Let's run the test. Unexpected number of diagnostics. I have my camera here. Let's go to the test. We have an unexpected number of diagnostics. We expected 0 but had 1. I think I didn't update some code from the inspection phase. Yeah, I pass in empty here. So this should be, that's actually, we don't need this anymore, don't we? Yes, can be gone. Let's run the test again. But we actually have 9 diagnostics. Okay. How do we have 9 diagnostics? Let's have a look at the generator. Maybe the source that you're creating is not good. Okay, perhaps when we throw, we should actually print the diagnostics for, let's do that. Let's not debug, but have a proper test. So where are we? Which one is failing? Here. The output compilation is 9 diagnostics. Okay, so let's for the diagnostic do basically the code that we had previously commented out here. Put it in here. So put out all the diagnostics. And how do we do that? Yeah, let's use that what we had previously. Those are the actuals. String diagnostics is, diagnostics is where we string join the messages, and let's pass in here as well So our throw needs another overload. We can pass in an additional message that we then just add at the end. Let's see what the output looks like. Okay, we should separate each line. So we string join by a minus and a new line. Or do we do the new line afterwards? Environment dot new line. Or we can always reformat later to make it prettier. Ooh, we have 9 views right now. That's amazing. Thank you so much for watching. Okay, yeah, here we get, okay, identify expected, there's top level statements. So I guess the class that so this is, yeah, okay. I emit this as source code. This is bad. We need to remove this syntax here. So for now, we need this later. I will remove this for now and try to figure that location out later on, and actually need to remove this because this is not valid C# syntax. And yeah, now we have unexpected number of diagnostics. We expected 0 diagnostics, but had 1. The warning on the class. Yeah, that's cool. But I thought we actually do expect it. So we have an issue somewhere in the inspection phase. Pass in empty here. This must be the diagnostics. I see I have the diagnostics several times. Is this always the same diagnostics? I guess I can boil it down to a single one. But let's first see if this is now passing. We expected 1, but was 0. Ah, so that's not the... No. Why do we have 0 now? Ooh, David Vengi is joining. Wow, that's amazing. I missed exclamation mark when you inspect the diagnostic IDE. When I inspect the diagnostic ID. So actually, not sure where I did miss the exclamation mark. Is it here? So we have 1 diagnostic, and I want to view if I guess they're all the same. I can boil it down to just one. Oops. Okay. Let's do it a bit more naive. It's an immutable array. The if statement, where you loop through the expected diagnostics. So this will be in the inspector. So for each diagnostic, if we actually have an ID that we can compare, and if it equals, then we throw. Yeah. Thank you very much, David. Yeah. Of course, I need to throw if they don't equal, and then put on the yes, yes, thank you. I also want to see if, like, the diagnostics that we get from the one generators and update compilation, the diagnostics that we get from the output compilation, I guess so, because it says update compilation, so should be the same. And then we have diagnostics from the one result. I wonder if they're all the same. I'm not sure. Oh, yes. Now we get the extra expected exception. So I expected, yeah, cool. Thanks for your help, David. I expected something with underscore, but it isn't. So that's cool. So we can actually go ahead and fix the test. Yes. And debug. Have a look. Okay, so the output diagnostics is the warning that we get. The diagnostic from the output compilation is no diagnostic. Okay. So this will fail. So let's expect here empty. I made a bit of an helper class where we, yeah, basically an immutable array of empty is diagnostics.empty. And the last one that we get from the one result is also the one that we expect. So, okay, so in our case, we don't need the one result diagnostic. We'll remove that. Okay, so this should be now a passing test. And then at the end of the session, which will be in like 45 minutes, we will then try to integrate this into an actual benchmark and see if this works as expected. Okay, so yeah, now we have a bit of a difference because I changed the input source that the generator gets, but not the expected output. So we now expect 2 nodes. I guess these nodes is the root compilation, what is it, compilation unit, and the class declaration. Cool. Great, passing test. Okay, for perhaps how to tackle this, I'll have a look at later on. Maybe I should do the actual thing first, because I now kind of get lost in the inspection, which is all pretty much done by Microsoft Code-on-Assist.testing as well. I just want to offer like a bit of a facilitator in this package without the dependency to do a bit of a plausibility test. but let's have a look if the actual thing is working. So let's write a benchmark. We have a example project here. It's quite empty. So let's have a look at benchmark.net. Are we actually, oops. Having the dependency yet? No, we don't. So let's pull in the latest version of benchmark.net. The follow-up that I wanted to mention is, let's have a brief look at, there is now a different solution, an actual generator that I wrote, which is published as a NuGet package, where we have a look at how testing with the diagnostics is done. No, let's actually have a look at a different solution. No, I think I have it in here actually, should be there. Let's search for diagnostic. There it is, yeah. Okay, so Microsoft.codeanalysis.testing has a diagnostic result type, which offers to create, so this is, as we see, Microsoft Codeanalysis.testing, and I believe that internally this type is checked against the actual diagnostics and asserted. And they have a lot of withers, so this is an immutable type. It's a struct. Yeah. I then will end up with probably something similar. Perhaps I should actually take the dependency on testing, but I'm not sure if perhaps to get a couple of types, but the actual one, I really can't, because the invocation, because their testing does a lot of things in one, but we need to split it up to have the invocation one be as small as possible, not do any additional work to have a real benchmarking result. But perhaps we take the dependency on the types. Not sure yet. And what I'm trying to get, actually I should show it. I always have like a very similar setup for benchmark.net, which is this one. Let me grab that. Go to the program file. So I already have it like this. So let's grab the body of the main method. Let's put it in here. So benchmark switcher, what this does, I will come to it in just a second after I included all the using declarations. Yes. So yes, I can get rid of this. Okay. So what we have, in order to have a meaningful benchmark result, you need to run the code in release mode. But there is also a debug configuration. So in benchmark.net, it's the debug in process config, which can be used so that I can basically debug the benchmark itself with Visual Studio with F5. But if the debugger is not attached, if we do a release build, then we should use the release configuration, where I test for with the .NET 4.7.2 and 6 runtime, add a couple of columns, and I always want the memory diagnoser. So this is just some facilitation. The benchmark still is pretty much the same. And let's add a benchmark. Oops, I call it class 1. I have no name yet. Benchmarks, I believe, need to be public. Let's jump to the documentation of benchmark.net. So we have a global setup. Okay, we need the attributes, and we also have a global cleanup for the inspection. I do want to have this inspection because a lot of times I see benchmarks which also in a different project, on the same project, also have a unit test in order to briefly validate if what the benchmark performs is actually correct. So we create our benchmark, which is the C# incremental generator benchmark. Can we get the project? No, I need to include it manually. Add project reference to incremental generator benchmarking. Yes. No type is available. Okay, we need a generator. Benchmark is new benchmark. And in the setup, we do the initialization. Then in the benchmark itself, we do the invocation. So this is where the benchmark there, or where the generator is run a lot of times. And at the end, we have an inspection. This takes the initialization context, and this one takes the inspection context. Now we need a generator. Which is I incremental generator. Doesn't need to be public, can be internal, but it does require the generator. Maybe in this case it doesn't, because we don't really load it. We just load it in memory. But for the completion, let's say language names.c#. This will be a C# generator. And it will just produce some output code. Let's say context dot add, no, build, what's it called? Which is the source output. Do we need a syntax provider? We need some value provider. Let's pass in the parse options. And we have our execute method. And generate the execute method, which can be static. With our context, we have our source. And let's produce some code. Let's say context dot add source. As a hint name, let's say my generated source dot g.cs, and we need some source code. I think we had an example previously. This would be suiting well for this example, but I believe I deleted it. So let's briefly write it again. We have a C#. This is what we did last time. We have a C#9 source code, which has always the auto-generated header, and well, let's in our case do let's do the same example that we had last time. Auto-generated, we enable nullable, we have a public, no, namespace, my namespace. We use a log scope namespace, public class, my class. And we do the same again, but this time with C#10, which uses a file scope namespace. And then depending on the pass options, language version. Oh, those are pass options. We need to pass them into C# pass options. Pass options equals in C# pass options casted pass options. And we can use these now to get the language version. And if this is greater than or equal to C#10, then we have file scope namespaces available and we use the C#10 version. Otherwise, we don't have file scope namespaces available and we use the C#9 version. So this example that we wrote last time, pretty much the same. Okay. And let's see. So we have setup, we have cleanup, and we have the benchmark where we invoke it. And let's run this benchmark. Let's see. Maybe let's do something bad. Let's say thread.sleep. So this is a slow generator. Let's sleep for 1 second. I'm opening a terminal and do .NET run -c release. So Quepis is asking, how did you get the little pop-up text when you hover over your code? I'm afraid I'm not sure. Do you mean like this? If you mean that, this is like totally built in into Visual Studio. I now have CLS compliant errors because I do have warnings as errors in the solution. Yeah. And since I'm doing a release build, now everything fails. So I will for now don't care about CLS compliance. I will have a look at this later on again. And the variable driver options is assigned, but its value is never used. So this is in our benchmark type. Yeah. But now I guess it's benchmark time. Yes. So we can now select one of the benchmarks that we have. This is because we have only one class in our solution, in our benchmark solution. Not solution, project. Let's jump back to the solution view. Okay, it's called class 1. Actually wanted to call it, how do we call it? My C# benchmark. Let's also rename the class. And this is because we use in the program of the benchmark, we use the benchmark switcher, which then, I guess reflection style, could also be done via source generator. Find all the, well, we are passing the type of, so I guess it's a reflection. Searching all types which offer benchmarks and then runs them. So we can now, since we only have one, we can select only one. And let's run the benchmark. And we have an unexpected number of syntax trees. Yes, because in our cleanup, let's create an object initializer. So this actually, create object initializer. This is an code refactoring that I wrote together with a friend of mine. And we will also benchmark this one in a future episode as well. So let's create an object initializer. And the source that we expect is, perhaps I will make this static here. It's a test generator, so that's cool. Internal const, let's move these, both of these up here. Where's my typo? There it is. Okay, and let's say my generator.c#10, because let's also create an object initializer for this one and say input source, nothing, we created out of nothing, and our parse options, a new C# parse options, which we explicitly set to use the language version C#10. And now it's benchmark time. And I have another error, cannot convert null literal. Okay, somewhere I violate. Ah, there it is. We have no diagnostics. Or we don't expect any diagnostics. Ooh, benchmark is running. So what's happening is that the setup phase is executed once, where we arrange how we want our benchmark to run, which language version to take, perhaps also which input source that the generator should take, because currently this test generator that we have doesn't observe the input, it just unconditionally, no, it does conditionally, but conditionally on the parse options creates source. It doesn't inspect via a syntax provider the code of the user. Oops. And then the invocation phase is run multiple times, a lot of times. There is some warm-up phase so that JITting gets a chance to create, or the JIT compiler gets a chance to create the most optimal version. And then the actual, I guess there is even more phases. I'm not all too deep in that. I need to read up on this actually again. Did it some time ago, but I forgot it. And then the actual benchmark is invoked many times, and then we get a lot of statistics because there may be some outliers. So we get the minimum, the maximum, the mean, the average. And at the very end, because we have the memory diagnoser enabled, there is one additional one for the allocations and the garbage collections to measure. And then at the very end, the cleanup is invoked to see, to clean up, which we will abuse here as a bit of a verification step. And our benchmark is in. So since we have both Net 6 and the Net framework, we get 2 here. And so this benchmark, this analyzer, this generator runs approximately 1 second. This is because of the thread sleep. So it is as expected. Cool. So basically this is basically it. What's now to do is support more scenarios. Because what we do support currently is basically passing in one source code. We can say the source is, what could we do? We could put in a class and then have our generator count these classes. So we can actually use a syntax provider. We create a syntax provider which gets in a syntax provider predicate, which filters syntactically, and we get a syntax predicate transform, which allows semantic transformation. Let's create both methods. I would like to have both of these static. And we get in the node here and a cancellation token. And we say we return if this is what we did previously, a class declaration syntax. So we find all the classes that are declared in the user code. And then return these. Oops. Please do a body block. Yes. And well, we can do actually debug.assert. Because we know that this node is a class declaration, because we filtered it up here. So we can actually be safe and return that here, casting it to a class declaration. And we return all the class declarations. We also have a cancellation token. So if you have like a loop doing something more expensive, then always pass in every Roslyn method that is called. If it takes a cancellation token, pass it through. So this syntax provider now gives us all the nodes, and we want to combine that. Well, we can collect these now because this is multiple nodes. This is a, what we see, a incremental values provider, but we want to boil it down as to a value provider. So we collect the results so that we can combine it with the pass options provider that we also bleed. I call this combined, and we pass in the combined here, which means we now have a new signature for our execute method. Let's jump to the execute method, pass it this new thing. So the more we combine, basically it's always a value tuple, or a C# tuple. And for every provider that we combine, we get another element in this tuple. So it's always like two tuples combined. So in this case, we have now basically a left and a right. And if we combine again, then we have what we see in this test benchmark generator. There it is. So where we combine a lot of providers, we see that this gets pretty long, this type. So we have like a right, and we have a left, and this left again is a value tuple where we have a right and a left, and this is again a value tuple where we have a right and a left, and again until we meet the end. So this is how the combination with this syntax value providers is working. And for our my generator benchmark, we can now, we need the options, which is in our case, I think the right, yes it is. Oops, I should call this one source. Pass in the right. And the left is the amount of class declarations that we found. So the next use case would be to allow more than just one generated source, because one generator can produce either no source or many sources. And this would be then my other source, which could be the number of classes, which is now our left, which is an immutable array. It has a length. And perhaps we should add this as a comment because it doesn't compile otherwise. So this would be the next scenario to not only support as an output or as in the inspection phase what is generated, but also as an input. Because usually a project consists of more than just one file. Or, well, file from a CSProc point of view, but more than one syntax tree from a user point of view, what from a Roslyn point of view. So this source should be a collection of sources. And then for the assertion, this should also be a collection of sources where we can then compare the hint name with the actual source that was generated. Sorry, I just read the message now. You don't have those pop-ups on your end. Are you using Visual Studio 2022? I wouldn't know how to disable those pop-ups. For example, if I hover here, what is hidden behind this target type new expression is this type. I wouldn't know how to disable those. Maybe there is a Visual Studio setting. I won't know how they are called. Maybe inline hints or something. No, I think the inline hints is actually something else. I'm not sure with which option you can enable those pop-ups when you have a code. I'm afraid I never had it disabled, so I wouldn't know how to enable it again. Okay. Yes, multiple sources. So let's change this into a sources. Or let's go into the test actually. First we need a test. Was this actually where I wanted to go with? Yeah. Here is our test. This is our production type. So in here, when we create, so in the initialization phase, we do create the compilation. And so here is what the compilation consists of. We have, perhaps let's format this a little bit. Crappies, thank you very much for the follow. I really, really appreciate it. Although I couldn't help you, I'm sorry. I'm not sure how to enable the hints. Perhaps I find it later on. If I find it later on, I will tweet about it. Let me add a to-do on my notes. To-do, enable, disable, Visual Studio type pop-ups. I will get to that in the afternoon, or in my UTC +2 afternoon. Yes, so we here the syntax tree that we create the compilation from, which consists of the user code. We have some metadata references, so we also want to make them references as input parameter. The metadata reference, for example, could be is it called a reference assemblies for .NET? So perhaps we could use the net standard 2.0 reference assemblies, so that then semantic checks. No, not semantic checks. Yes. Semantic checks then have all types available that the net standard 2.0 has. Like, for example, system.string, but doesn't have like net core types available, such as span of t. It's not in standard 2.0. And the C# compilation options that we already use, for example, to set the language version. No, that's the parse options. What's the compilations options? Compilations options are for the output kind, if it's a library or an exe, or whether to enable optimizations. So debug or release, and I guess release. So if we have debug, we don't have optimizations, so we can actually step through the code, but release may remove or rewrite code, and then debugging would be not possible anymore because the source has changed. Well, not the source has changed, but it differs from the original source, and so on. So we perhaps also need to enable passing the compilations options. But the parse options we need in order to create the syntax tree, because each syntax tree also has parse options it has been parsed with. For example, using C# 10 or C# 9. What else do we have in the parse options? Preprocessor symbols, for example. Okay, but we do, so we see we create an array of just one text. So there should be multiple texts. So what we want is basically some select. We have context.source. This should be source says really. Select, where we then for each source then create a parse options. Yes, so but now we need the sources. I guess but we could allow one source, because this is like the most common case, I guess, for tests, to pass in just one test. And so we could make additional sources. And I have a déjà vu. I think Microsoft.codeanalysis.testing is doing it very similar. So passing one source is super common. So forcing this to be an array would be, I guess, not so nice to be usable. But then we have additional sources, which is then any enumerable of string. And now let's make this non-nullable, but per default there is none. Then for each additional source we add, which means that we need to have one and then add, is this easily linkable? I will care about that later one. But we have sources, additional sources, it should be called. Oh, so Crep is, you have this issue for a while now. Yeah, perhaps, hope I can help later on. I'm using Visual Studio 2022 so that I can reproduce the issue on my local machine here. Additional sources. And for the test, let's copy this test. And let's have multiple. Oh, I want to copy this one really. Okay, about the diagnostics, yeah, we will tackle this later. This is not so important right now. We have basic inspection. About the rest, to have more forward inspection of diagnostics, we will tackle later. And also this syntax we need to tackle later. So if we have multiple sources, multiple input sources, so we have a class, and then as additional sources, let's call this my class 1. And as additional sources, we pass in my class 2. And let's also pass in a struct. Okay, what am I doing wrong? This must be... I don't need this, do I? Oh, because it's okay. Perhaps I make this a separate type to enable collect. This is a collection initializer. Perhaps if I make this a separate type, not IEnumerable, but like some collection. What if I just make it a list? Why not? Is there an empty list singleton? Not really, is there? So let's do a private static read-only empty list. String, which is like really empty. And we need a type. Per default empty list. Okay, some analyzer suggests to use collection of T or read-only collection. Okay, let's use collection. Okay, and now this should enable, yeah, now this enables collection initialization. And now our testing generator could do the very same that the other generator that we did, is that it returns true only for class nodes. If the syntax node is a class declaration syntax, which means we need to update some test. Yeah, because this empty test node still has no node. This test has one class node, so let's have this one. And this test now has two class nodes. Yeah, there's also a struct, but the struct is not a class. And let's see how this test is doing. It's failing as expected. I'm looking at the clock. We have like 10 more minutes until we stream 2 hours. So perhaps I'm able to finish this. We have an unexpected number of diagnostics. Oh, we actually have diagnostics. Okay. Perhaps I should always do this. So if they are equal, for now I will do some refactoring there afterwards. But if we have like a non-matching amount of diagnostics, it would be nice to view them. The namespace global namespace already contains a defined class 1. Okay, I have class 1 twice. 1 to struct. Does the generator quit? No. Okay, where is the class 1? I have class 1, class 2, and a struct. The global namespace already contains a definition for class 1. I'm not sure where this is coming from. Oh, yes, 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 because I am... No, that's not it. Context source. Yes, that is it. I make a mistake here because I iterate through the additional sources, which are 2. We'll have a look at this question just in a minute. The additional sources, but I then use the other source. Yeah. Okay, not sure if this will be the nicest code, and I need to combine this with the original code. So if I say, how can I like link style combine 2 collections? It's not combine, it's equals except, no. Concat, yes. And I concat that with a new string array of the other source. Okay. So this should now we should have all sources, but only once, and concat so I have okay, I need to concat the additional sources. There we go, and then join that. So we concat the additional sources with the other source, and then select the parse options. All right. And this makes the task pass, so that's cool. We have 2 class nodes. The struct node is not analyzed, I believe. Let's actually get it briefly to fail if we always return true. Now the text should have a difference here. Expected nodes should be 2, but actual 3. 6. Yes, because we have three document roots. So the compilation, we have 3 compilation units which each contain 1 class or a struct, so 1 type. So we add 3 multiplied by 2, so we have 6 nodes. Yeah. So this makes perfect sense. So let's in the generator have this again. Okay. And going into the chat, and does the collection initializer, when used like that, create a new collection? Or is it adding things to your shared static empty collection? I believe it's adding to my empty one, isn't it? Ooh, yes, I see the issue. This would, if we call multiple, let's have a test for that. Fact void something like contexts are immutable or not. Yeah. So this will be my initialization context. Let's create one. And say additional source, add a new source. So it's init only. So let's see if this is a problem. And add one string here. Doesn't matter. And then we expect, if we create a new one, I call it, so this is context 1, and we create a context 2. Now from context 2 dot additional sources assert dot, is there like some, okay, perhaps now fluent assertion will come in handy. Let me briefly add that, because I really like fluent assertions when asserting collections. And we can say, so context 1, additional sources should have count of 1, but the additional sources of context 2 should have 0. And it fails because additional sources also has, now also has 2, has 1, found 1. Let's call this context 1. Now we see, yeah, thank you very much, David, for the hint here. This would have been a terrible bug. So when we initialize it like this, so I guess we should have something, yeah, we should really make this immutable. Or, well, at least this original source, this one should be like super immutable. But how do we best? Well, I guess the quickest one is to always create a new collection here, not have this shared one. And yeah, static mutable state is very bound to cause issues later on. Thanks for the hint. So this should now have this test passing. Cool. And let's run all the tests. Excellent. And for the last action of today, let's also integrate this into our actual benchmark to go to our test benchmark. Close all but this. And let's add some additional sources, but let's add a lot of additional sources. Let's have a list, string, additional sources, new collection, let's make 1,000. Then for each, before over 1,000 elements. Does the collection have like a capacity? Yes, excellent. So we can use 1,000 here again. Don't need to duplicate the literal. And we add public class, and let's add the index to that class. And now we add 1,000 classes. So in the generator, oops, where's the generator? There's the generator. Maybe let's remove this 1 second delay. And let's make it 1,000, and then let's have later on a look at how it performs with 10,000. So we now also do additional sources. And this doesn't work because one is a collection. I thought a list doesn't implement collection, but I collection, doesn't it? Yes, but collection. So yes, this too. Array. No, array does not. It's not a collection. Okay, this will be more of a hack for now. I'll refactor this later. Perhaps collection is here an unsuitable type. Maybe this needs to be some custom type. I guess at the end it should be a custom type because we also want to have like the hint path, the hint name of the generated source. But for now we create a collection and pass in this list. Good enough for now. Since this is the setup phase, this is not performance critical. The invocation phase is. And let's run the benchmark. And okay, expected. In the cleanup, I expected 1002, but we had actually 1003 nodes. Hold on. Unexpected number of syntax trees. We have one too many because I guess we missed the original one. Conquered and selected, and diagnostics, syntax trees. I will, since time is running out, I will have a look at this later. For now, I comment out the inspection phase. Let's care about the benchmark really. What do I think about Mac for coding? Well, I never used it, but there is plenty of tools as well, Visual Studio Code or Writer, and I regularly use both Visual Studio and Writer. Currently I'm in Visual Studio mode. In a different stream I may use Writer, and you could also use that for development. I never used Visual Studio for Mac because I never used a Mac before. But I think recently there's also the latest version was released. Well, it's currently not my preference, but I heard it from other developer that it works at least just as well as with Windows. Zepcode asks if this is similar to benchmark.net. It's basically enabling, so it's depending on benchmark.net. So we require benchmark.net in order to benchmark Roslyn components. The thing is that I so far didn't really find anything which enables benchmarking, because the core part is that you need the driver. So you need the setup is the C# generator driver that you need to create, and then in the invocation phase of the benchmark in benchmark.net run this over and over again. And well, this isn't a lot of code, but I have it now basically copied something similar set up, copied, pasted in 3 projects of mine, and a fourth is coming. So I thought like, okay, perhaps this I should make this a library to have this at one central place and not copy paste code all over again, and basically merge all the functionality into one. And additionally, what I also want to combine it with a very small part of Microsoft.codeanalysis.testing in order to enable an inspection phase to have a very small test if everything is as expected after the generator has run. I suppose that you must be using the compiler to add sources into the project for benchmarking. Zepcode asks, yeah. So I use the Roslyn API. I have here the create compilation method where eventually I do C# compilation.create. So this is then what I guess Visual Studio or the .NET tooling does in the in the behind. But yeah, so the actual tooling is based on using really source files, which are on the disk that the user has written or the developer has written. But in this case, we are using it from source code. So this is just in memory representations. Nothing is written to disk here. This is the big difference between what Roslyn is doing in production basically and what we are doing here for testing or benchmarking. You like the idea? Oh, that I really appreciate that. So that means that perhaps this package is maybe also not usable to me, but perhaps something else from the community as well. This would be great. Yeah, so the benchmark is, I think this is the questions from the chat. Benchmark is failing because, warning says errors. It's really strict. And let's run the benchmark. So I will then off stream find out the issue that I had here because we are already over time. But I really want to finish that thought. So first, what you see, there is the overhead warm-up, and actually, okay, I'm not sure what's overhead warm-up and overhead actual. I need to read up what the difference is. I thought there was like basically a warm-up and then the actual, but there was some overhead warm-up. I actually need to read up on that. And so this allocates 1 byte and takes 2 milliseconds to run. What happens? This will be the last test for the day. If we up that number, not to create 1,000 source files, but let's create 10,000 of source files. So this is a bigger project. Well, okay, it's not a source file, but a syntax tree. Each of these documents, in-memory documents, only has 1 class and it's super small. But let's see if there is a notable difference. Because previously when he had like this thread sleep for a second, we noted it immediately. And now this should it allocate 10 times of the memory? Perhaps this should be not 10 megabytes. And duration should be, I'm not sure, 10 milliseconds? Let's see. And okay, now we allocated 23 megabytes and approximately 200 milliseconds. But yeah, so the thing is that the filtering, so why this takes so long is we have 10,000 classes and the generator, so this is definitely not the best generator because for the syntax provider, when it comes to syntax nodes, should really filter in the in this syntactic check, it should filter as much as possible and as quick as possible, and basically including every class. There may be a lot of classes in the solution. Or in the project. One thing about incremental source generation is that if we would run it again, then it wouldn't be as notable because it uses internally memorization. So if nothing changes from the input, then the later steps don't need to be executed because it's the same. So basically we would create the very same source again, or not really create it again because it's already there, or it's cached internally. And we can simulate this by, this will be now the very last move. And this is now the big difference between Roslyn 3.8 source generators and Roslyn 4.0 incremental generators. By, if we have in the invocation phase, if we reuse the result. So if we actually reuse this driver and assign the driver, and then in the next invocation, we use the resulting driver, which now has some cache results. I'm not sure if one generator is all white or if we need to do one generator and update compilations. I will use that because this is where we definitely can see the difference. I will discard the output compilation and the diagnostics because we don't need them here. And we'll just run the benchmark again. And now it shouldn't take 200 milliseconds anymore. It should be now quicker because only the first one takes that long time because everything is analyzed and created. But then future ones, or every subsequent one, because the source doesn't change between the invocations, the output doesn't change. So they should be now much quicker. And in the IDE scenario, this would be if user adds some code, but as long as they don't add a class, and since the generated output is depending on available class declarations, and if we don't add or remove a class or change a class declaration, then nothing is changing in the output. And this is when the internal memorization / caching can be very powerful while developing in an IDE with incremental generators. And we see a huge difference. This only allocates now in a mean 700 kilobytes, and it's just 1 millisecond because it's only the first invocation which is slow. Every subsequent invocation is super fast. And this is the power of incremental source generation. And yes, so Zeep code, this is exactly the project. I haven't pushed any real code yet. Perhaps I will do this in the evening, UTC2 style, to actually push what we have so that you can have a look at it. I haven't pushed anything. Yeah, the current data repository is quite empty. And David asks, I wonder if that should be a parameter to the invoke method. Then the user could compare incremental and non-incremental scenarios. I actually had this idea. I discarded it again. But now that you write it, I shall bring it back. This sounds like a use case. So this will be just to add. And I guess we will make this parameterizable next time. So to do, it is the context, so the initialization context, init context should have switch for disabling or basically enabling. Not sure what the default should be. Because if it is, since doing a benchmark, the source doesn't really change. So I'm not sure how valuable. Well, okay, yeah, it really depends on the scenario. Do we want to optimize for because if we do just a .NET build, then the generator is basically run once, and there is no difference between incremental and non-incremental generation. In an IDE scenario, there's a difference. So yeah, I guess this is a super valid use case. So in the context should have a switch for enabling or controlling incremental generation. I think this is called internally the memoization, if I write that right. Caching, I know that word. So this should be like a switch here. Bool, perhaps I disable it per default, but enable incremental generation. So that per default, it behaves exactly as the benchmark for an iSource generator, because an iSource generator doesn't have this. But the incremental generator now offers this option, which is not the default, but can be opted in. That's a to-do for next time. And yeah, we will start with this next time in pretty much in 1 week minus 2.5 hours. And let's have a look at our discussion. I will also, yeah, so currently, where is it? So currently the repository is dramatically empty. There's only the initial commit. I will push some code later this day, what we have so far. And I get a new follower, Seb Code. Thank you much for following. And yeah, I really hope to see you perhaps next week again. Yeah, so this is the discussion where I will update this immediately now with all the new links that we inspected. And yeah, we indeed had a follow-up on this first session, and we continued implementing benchmarking. For the next session, we again do in 1 week, do a bit, and also again David Venture as a follower. Thank you so much. I really, really appreciate it. Where we will start with a bit of a follow-up, what we did and learned this time, and then implement this memoization. And then, yeah, continue on having a look and also enabling the hint text as an expected for the generated sources, and also take a look at the diagnostics, which to make a similar experience to Microsoft.codeanalysis.testing, which we also need later on which we definitely will need later on for benchmarking components of diagnostic suppressors, because they heavily depend on, or in general, analyzers as well. So we definitely need to need this also for the invocation phase in order to enable benchmarking of analyzers and also diagnostic suppressors. Cool. Then the last few questions. Oh, Zepcode start the repository. Thank you very much. Appreciate it. This is the first star, isn't it? Yes. First star. Thank you. Thank you so much. This is amazing. Although it is empty, there will be content in the next hours. I don't really understand incremental generation. Could you explain it? I hope I did this now. Otherwise, I'll just follow up on this next time anyway, because we built this enabling incremental, non-incremental generation. And we will also build a component for the iSource generator within Roslyn 3.8, which doesn't support incremental generation. So there will be a follow-up to that. And I now stream every Sunday from 7 to 9 o'clock. Well, it's now 9:30 already, UTC, to build this library. I expect to need like a month per component. So at the end, maybe in half a year, we have this all ready. But let's see how it goes. Thanks for the reminder to follow. Thank you very much for following. And with that, I am 20 minutes over. We took care of everything. Yeah. So see you, or read you in 7 days minus 2.5 hours. And with that, I want to thank you very much for staying around and listening. Goodbye. I always forget to start this beforehand, to have the finishing banner. Now this is awkward. awkward moment of, now I'm gone.